Hey, Algebra 2 Honor students, welcome back. I hope you guys had a great spring break. As promised, here's a video that I told you guys that you would have to watch on this day. Remember, we're going to kind of crank through a lot of notes on Tuesday and Wednesday, and then Thursday and Friday, you guys are going to have a lot of time to practice. So bear with me here. Please make sure that you watch this video, rewatch the video as many times as you need to make sure that you have a solid foundation. So we are starting in section 14.1. All these properties that we're going through, you'll also see in the book. So we're going to start right away by talking about our reciprocal properties or identities that we'll be using to do trigonometric proofs. So the first one that we have cosecant of x is equal to 1 over sine of x. Hopefully that's familiar to you. We have secant of x is equal to 1 over cosine of x. And then we have cotangent of x is equal to 1 over tangent of x. Right, so those are ones that we've seen already when we were starting to do, trying to evaluate these trig functions using the unit circle. What might not be so familiar to you, now we will use these regularly, so make sure if you haven't written these down formally somewhere that you do. Some properties that might not be so familiar, we haven't fully discussed in detail, are quotient properties. Okay, so we've got tangent of x is equal to sine of x over cosine of x. Let's do a quick little sidebar since we haven't seen that yet. Let's just make sure that that makes sense to us. So I'm going to actually start with the right-hand side and manipulate that because that's a more complicated version of the two sides. As we go through proofs, you're going to notice that that's going to happen a lot. You'll want to stick with the more complicated side of the equation and try to simplify that down to get to the more simpler side of the equation. So sine of x over cosine of x, if I think about this as ratios of being in a right triangle, sine of x I can rewrite as the opposite side over the hypotenuse side. And cosine of x I can rewrite as the adjacent over the hypotenuse side. And then I'm going to simplify that fraction. I know that I can rewrite division as multiplying by the reciprocal. So I'm going to multiply by the hypotenuse over the adjacent side. And then this is where I'm starting to see, okay, those hypotenuse sides are going to divide out. And then I'm going to end up with just the opposite over the adjacent side. And that is tangent, right? So sine of x over cosine of x is equal to tangent of x. Similarly, we can kind of walk through that same proof to say that cotangent of x is equal to cosine of x over sine of x. At this time, you should pause the video, just make sure that you can get that same result. So remember, starting with the more complicated side, you'll do cosine of x over sine of x and start simplifying. And you should be seeing that you've got adjacent side over the hypotenuse side, over the opposite side over the hypotenuse side. That's going to be equal to the adjacent over the hypotenuse multiplied by the hypotenuse over the opposite, which the hypotenuse sides will then divide out. So you'll end up with adjacent over opposite, and that's cotangent of x. We also have that tangent of x is actually equal to secant of x over cosecant of x. And cotangent of x is equal to cosecant of x over secant of x. These ones aren't, they're maybe not as obvious. So let's walk through one of them. And you should also make sure that you're capable of walking through the other. So again, I'm going to start with the more complicated side. So I'm going to start with secant of x. I'm going to walk through this guy right here. So secant of x over cosecant of x. If I think about those as ratios of a triangle, right? Or actually, I'm just going to think about them as their reciprocals, actually. Let's do 1 over cosine of x divided by 1 over sine of x, right? So Secant of x is 1 over cosine. Cosecant of x is 1 over sine. I'm going to go ahead and rewrite this as 1 over cosine of x multiplied by the reciprocal of that denominator. So that's multiplying by sine of x over 1. So that's then sine of x over cosine of x. And we know that that is the quotient property for tangent of x. It's not the only way you can do that proof. It's just one way. Okay, and then similarly, I'm going to let you guys go ahead and work through showing that cotangent of x equals cosecant of x over secant of x. You should try that on your own. Just make sure that you're getting some familiarity with manipulating these functions. Okay, now let's actually practice simplifying some of these. I have it down a little bit further. So your goal is to take problems 1 and 2, and you want to simplify both 1 and 2 into a single expression. So either a single trig function or a single number. You're just only allowed to have one expression in your final answer. Go ahead and pause the video. See if you can manipulate these expressions. Okay, so sine of x times cotangent of x can be rewritten as, cotangent can be written as cosine of x over sine of x. And then the sine of x's can divide out. So you should be left with just cosine of x. And that's my single expression. There's a couple ways that you can walk through problem number 2. So your answer you might not have gotten to the same answer in the same way. However, if you have the final simplified expression, then you're fine. So there's a few ways we can do this. So sine of x times secant of x times cotangent of x. I'm thinking of cotangent of x as cosecant of x over secant of x. And the reason I'm thinking of it that way is because I see the secant of x in the problem. Okay, so I rewrite cotangent of x as cosecant of x over secant of x. And then those secant of x's will divide out. And then I see sine of x times cosecant of x here. And cosecant of x, I know I can rewrite actually as 1 over sine of x. So this is times 1 over sine of x. And then that actually simplifies to 1. So your final answer for that one should be 1. Okay, and then we have a few more identities that we're going to introduce here. In one case I call them properties, in another case I call them identities. Again, the important thing is that you're able to manipulate these. So the Pythagorean identities are actually, as you would think, they're built off of the Pythagorean theorem. So the Pythagorean theorem says a squared plus b squared equals c squared in a right triangle. Now in a unit circle, our radius is 1, and we're going to go ahead and let that radius be any number for this problem to kind of see why this will always work, hold true. I'm going to think about these in forms of trig functions. So what I want to do is I'm going to rewrite a and b in terms of trig functions to try and see how this can turn into a Pythagorean identity with trig functions in them. Okay, so let's go ahead and talk about theta, and let's talk about how could I write a in terms of theta. So I'm seeing a is the adjacent side, right? So if I'm looking at cosine of theta, that's going to be a over c, right? Because cosine does adjacent over hypotenuse. So then I can rewrite a as c times cosine of theta. Similarly, I can think of sine of theta is b over c. So I can rewrite b as c times sine of theta. Right? And if you're not sure how I did that, I just multiplied both sides by c, right? To go ahead and divide out those c's. Okay, so now what I'm going to do is I'm going to take this expression and I'm going to replace a with that expression. I'm going to take this expression, I'm going to replace b with it. So let's see what happens there. So that means I have c times cosine of theta, that quantity is squared, plus c times sine of theta, that quantity is squared. and that should equal c squared. Now, because this is all multiplication, right, this is c times cosine of theta, I'm going to actually square both those terms. So this is equal to c squared times cosine squared of theta plus c squared times sine squared of theta, which equals c squared. And then I'm noticing that all these terms have a c squared in them. So I'm going to factor out c squared. So the left-hand side is c squared times cosine squared of theta plus sine squared of theta equals c squared. And now I can go ahead and divide both sides by c squared. And so as a result, I get my first Pythagorean identity, cosine squared of theta plus sine squared of theta is actually equal to 1. Okay, so this is the first Pythagorean identity of 3. So let's kind of jot that down, make sure we've got it here. Cosine squared of theta plus sine squared of theta is equal to 1. Now, this is super helpful. Recognizing cosine squared of theta plus sine squared of theta helps you simplify expressions so fast and so easily. But I want to kind of highlight that this expression, I might see this identity in multiple different formats, right? So if I think about, if I were to just subtract cosine squared of theta here from both sides, I could actually see this identity as sine squared of theta is equal to 1 minus cosine squared of theta, right? So maybe I see this expression 1 minus cosine squared of theta, and I just replace that or substitute it with sine squared of theta. Or maybe I see sine squared of theta, and somewhere else in the problem I see cosine of theta, and I want to get those to divide out, so I replace sine squared of theta with 1 minus cosine squared of theta. So being able to manipulate this entire identity is really important. Similarly, I can really rewrite this cosine squared of theta, right, is going to be equal to 1 minus sine squared of theta as well. Right, so recognizing it in this form is just as important as this form is just as important as this form. Now, a second identity actually comes from us just saying, well, what if we were to divide both sides of my equation by, let's say, we want to divide it by, let's do sine squared of theta. So let's divide both sides of my expression by sine squared of theta. So what happens here is this is cosine squared of theta over sine squared of theta. That's just going to be cotangent squared of theta. Plus sine squared of theta over sine squared of theta is 1. And 1 over sine squared of theta is cosecant squared of theta. So I get my second Pythagorean identity that says cotangent squared of theta plus 1 is equal to cosecant squared of theta. And I can rewrite that in so many ways, right? So I can do let's do cosecant squared of theta is, 1 is equal to cosecant squared of theta minus cotangent squared of theta. Cotangent squared of theta is equal to cosecant squared of theta minus 1, right? I can kind of manipulate that in multiple ways. Let's go back to cosine squared of theta plus sine squared of theta equals 1. I want to develop our third and final Pythagorean identity here. So let's say that instead of dividing by sine squared of theta, let's say that I actually divided by cosine squared of theta. What would happen then? Well, then my first expression is 1. My second expression is tangent squared of theta now, right? Sine over cosine, as we know, is tangent. And 1 over cosine, we know, is secant. So 1 plus tangent squared of theta is equal to secant squared of theta. And again, you can manipulate this. You might see this in many different ways, right? So you might see tangent squared of theta is equal to secant squared of theta minus 1. You might see 1 is equal to secant squared of theta minus tangent squared of theta. So just being able to recognize, one, the identity as a whole, and two, the different ways that you can manipulate that is really important. And I don't want to make this video too long, so I am going to we're going to do a couple examples of using all of these properties combined. So let's try simplifying the expression 1 plus cosine of x times 1 minus cosine of x. Let's see if we can simplify that completely. This is a multiplication problem, so I'm going to actually go ahead and multiply this out. Right, so this is 1 minus cosine of x plus cosine of x minus cosine squared of x. If I simplify these two, negative cosine of x and positive cosine of x, simplify to 0. And so this is 1 minus cosine squared of x. And so 1 plus cosine of x times 1 minus cosine of x, we can rewrite as 1 minus cosine squared of x. But if I go back up, I'm going to recognize 1 minus cosine squared of x is the same thing as sine squared of x, right? So I see that here. It's rewriting that first Pythagorean identity in a different way. So I can say this entire expression is just equal to sine squared of x. And I'm done. So that was example 1 there. Let's do a second one. Let's have you guys try simplifying. Let's do cosecant of theta times cosine squared of theta plus sine of theta. Go ahead and pause the video, take a minute, see if you can simplify the expression. In this case, I want this to actually simplify to one trig function. Okay, so if I rewrite this, this gets a little messy here, huh? So cosecant of theta is 1 over sine of theta times cosine squared of theta plus sine of theta. Now if I'm going to add those two together, I'm going to need a common denominator. So I'm going to multiply the second fraction by sine of theta over sine of theta, right? And so this is cosine squared of theta over sine of theta plus sine squared of theta over sine of theta, which that can be rewritten as cosine squared of theta plus sine squared of theta over sine of theta, because now they have the same denominator. And this right here is our first Pythagorean identity that we had developed up above. That's going to simplify to 1 over sine of theta. And 1 over sine of theta can be rewritten as cosecant of theta. So this entire expression just simplifies to cosecant of theta. Okay, and then we're going to do one more example. We're going to make it a little more complicated. Maybe we'll do 2 more examples. We'll see how much time we have. So let's simplify the expression cotangent of x plus tangent of x. This is actually going to be 2 trig functions. We're just going to try and get rid of that addition symbol there. So let's see if we can kind of combine this, condense a little, make it not so complicated. So cotangent of x plus tangent of x. I'm going to rewrite these in their quotient forms. So cotangent of x is equal to cosine of x over sine of x. Tangent of x is sine of x over cosine of x. I need a common denominator here, so I'm going to multiply this first fraction by cosine of x over cosine of x. I'm going to multiply the second fraction by sine of x over sine of x. So I get cosine squared of x over cosine of x sine of x plus sine squared of x over cosine of x sine of x. And that brings me to one fraction, cosine squared of x plus sine squared of x. This looks like I'm getting more complicated, but I like the fact that I'm seeing cosine squared of x plus sine squared of x because that is my Pythagorean identity. So that's going to simplify to 1 over cosine of x times sine of x. And I don't want to leave this in fraction form, so I'm going to actually rewrite this as 1 over cosine of x times 1 over sine of x. And I'm going to rewrite those as secant of x times cosecant of x. And there I'm going to end it. Okay, it has only been 20 minutes, so technically this should be a 25-minute video. I know you probably paused in some spots. You might want to go back and rewatch it. But just for the sake of having this there and you guys having access to it, I am going to go through one more example. So let's say that I actually ask you to take the expression sine of x over 1 plus cosine of x, and I want you to turn that expression into 1 minus cosine of x over sine of x. So basically I want you to prove that these two expressions are equal. Okay, so let's go ahead and start with that left-hand side. This is tough. So what I'm seeing here is I'm seeing 1 plus cosine of x in the denominator, and I'm not a huge fan of that. Why? Because I have two expressions in my denominator, right? So this is two terms, and that's a little more complicated. I can't just like split the fraction over the two separate terms. So what I'm going to do is I'm going to get a little creative here. I'm going to actually multiply the left-hand side by the quantity 1 minus cosine of x. And that might seem a little nuts, and I'll explain why my thought process goes to that. Okay, so if I multiply by 1 minus the cosine of x, that's actually the the conjugate of what's currently present. And so what's going to happen is I'm going to turn this into two expressions, right, where both of those expressions are perfect squares. So this is creating a perfect square factorization here. And that perfect square factorization in the denominator is going to end up being, so I'm going to rewrite the numerator here, sine of x times 1 minus cosine of x. That denominator is actually going to be 1 minus cosine squared of x. If you're not sure, go ahead and multiply it out, although we did that earlier. And because we did that earlier, we happen to know, and because we have our Pythagorean identities, we happen to know that that denominator is now sine squared of x. So that is helpful because guess what I wanted on the right-hand side? I wanted sine of x as my denominator. So I'm part of the way there. Let's see if I can get all the way there. So this is now sine of x, and I'm seeing it immediately as soon as I write that down, right? This is sine of x is getting multiplied by that quantity. So at this point, I can divide out one of those factors of sine of x, right? Because this is multiplication. So I'm going to divide out one of those factors of sine of x. And so now this is 1 minus cosine of x over sine of x. And at the end of the day, I just went ahead and showed by transitivity that that the left side is equal to the right side. Sine of x over 1 plus cosine of x is equal to 1 minus cosine of x over sine of x. Done. Okay, that's it for our videos for today. I'm going to let you guys go ahead and let that sink in, and tomorrow we will start with some practice problems, and then we'll move right into section 14 too.